Hello everyone, today we will discuss one problem known as container with most water. The problem statement is you will be given with one array called height. So you can think each and every value of this array as some bar and they are placed in a gap of 1. So here if you see 1, 8, 6, 2, 5, 4, 8, 3, 7 they are placed right according to their height. So now you imagine you are pouring some water from the top and this 2 bar can contain some water. So here the bar height is 8 and here it is 7. Obviously it can maximum store the water of the minimum height bar between them, right? Because if you pour more water it will be flown down from here, right? So now any 2 bar can contain some water, but what we have to do is we have to find the container which can contain the most amount of water. Suppose for this bar 1 and this 8, if you check here, the maximum water it can hold is only 1, because more than that it will be overflown. Similarly for others also, suppose this is the one bar 8 and this is one bar 6. So the highest water it can take is height of 6. So now how we can calculate this, we have to check next. So how to approach this problem? So the first brute force approach what we can take is we can compare each and every bar with other bar and calculate the amount of water it can hold. Then we can replace one variable value called max and we can keep on updating it if the new value is more than that. And at the end of the array we can get the maximum amount of water. Suppose for that purpose we'll start from the first one and then we can check for the other bar. Suppose from 1 and 8 if we compare, the water it can contain is 1. Then if we move to the third bar, not by changing the position of the first one, then it can contain the total water as 2. Then here it will be 3. Here it will be 4. Here it will be 5. Why it is 5? Because this part can hold the water. Then this part can 6. This part can 7 and this part can 8. So if the position of this first bar is fixed and if we compare with each and every bar, the total means highest water it can hold is 8. So suppose that value I have updated. Now similar fashion we can make this one as fixed, then we can check for the other bars and get the maximum water it can hold and keep on updating this max value. So in this way we have to compare each and every bar with the other bar and check like how much water it can hold. So how we can implement that? For that purpose we have to take one for loop which will maintain this constant part, and then in the inner for loop we have to keep on updating the or keep on moving from left to right, and then we have to calculate and update the maximum variable. So the time complexity will be in this case O(n) square. So now if we have to check that somehow if we can reduce this to O(n). Now we have to check if we can do it in one pass, means you will traverse the array once and we will get the result. So what we are doing earlier is we were comparing each and every bar with the other bar and calculating the amount of water it can hold. But is it really necessary to do that? Instead of that, what we can do is we can take 2 pointer. One will start from the left side, one will be from the right side. And first only we will get the maximum water which will be contained by this one, right? So in this case if you check, the water it can contain is 8. Now whom we have to move now? See, the minimum between these two is this one. That means if I will move it forward, then there is a chance that I can get a higher bar which can hold more number of water. So that's why minimum of both the bar we have to move forward or backward, you can say. So in this case 1 is less than 7, so we have to move this one towards the right side and we will get a new area which is containing 49 water. Now we have to move the right side from here. Why it is? Because between 8 and 7 was lesser, so we have to move it towards the left. Then we have to calculate the water, and it will be 18 in this case. It will hold this much amount of water. Then between this, which one is less? This one. So we have to move it to the left side, and then we have to calculate. And in this case, how much water it can contain is 40. Next, among both of them, both are same, so we can move any one. So let's move the left side one. So we will move the left side one and calculate the water, and the water amount will be 24. 6 into 4 in this case, right? So between 6 and 8, 6 is less. So we have to move it to the right side. And how much water it can contain is 6, because 2 into 3. Then between 2 and 8, which one is lesser? 2 is lesser. Then we have to move it to the right if we can get something better. So if we move it to the right, we are getting 5 as our next bar. And how much water it can contain? 5 into 2, that will be 10. Then among 5 and 8, 5 is less, so we have to move it to right if we can get something better. Then the new height will be 4, and the water it can contain is 4 into 1, that is 4. Now we can't move it further because we have to maintain the left always should be less than the right. There we have to stop. So now this is the position we have to stop, and among all these values, whatever will be highest, that will be our result. So 49 will be the result, means 49 is the highest water it can contain, and the area is this part. So if you see here, this part is the 49 value. So while iterating, we will keep one variable called max, and we will keep on updating it. So at the end of the loop, we will get this as a result. So in this case, the time complexity is reduced to On. If you can say in the best case scenario, it can be On by 2 also. Now we will do the coding. Okay, so now we will start with the coding. So first we can define one variable called left, which will be 0, and right will be our this height length minus 1. Now we have to define one variable called max, which will hold the result, and we can initialize it to the minimum value of integer. Now we have to continue it while left is less than right. So first we have to check which one is minimum between these two bar. So math.min will be a height of left comma height of right. And now if the result will be like the volume of water it can contain, that I can replace. So suppose previously this was maximum, we have to check the new water it can contain is min into right minus left. So that is the amount of water it can contain, and if it is greater than the previous max, we will update the max one. So that is the way we will get the new max if it is there. Then we have to do one thing, we have to move the pointers. So what strategy we can play here is, if the height of left is suppose less than or equal to the height of right. So in this case what we will do is, if left side height is less than the right side height, so that time we have to do a left plus plus, or if it is equal also, or else we have to move the right side one. Right side will be minus minus because it is moving from right to left, and at the end we have to return the result as max. Now we will submit the solution. Okay, compilation error we are getting. Yeah, yeah, so it is accepted. Thanks for watching this.